two random variables x and y are described by the density function described by the density function fxy x comma y is equivalent to a times x plus y. For 0 to 1 and 0 to 2. Both x and y are lying in the interval 0 to 1. So this is the joint probability density function of the random variables x and y. Find the value of a, find the value of a and the joint CDF. Find the value of a and joint CDF. Understood this? So how can you evaluate the value of a? That is volume under that function must be equivalent to 1. Therefore, integral minus infinity to plus infinity, this is fxy x comma y dx dy must be equivalent to 1. So here both x and y are in the interval 0 to 1. So therefore 0 to 1. In that interval it is given by a into x plus y dx dy is equivalent to 1. Therefore this can be written as 0 to 1 you integrate with respect to x first. Then what you will get x square by 2 plus xy from 0 to 1. Then see 1 by 2 and this is y. So you will get 1 by 2 y and y square by 2, 0 to 1. Therefore this implies a is equivalent to 1. Is it right? So it is the double integral. First we are integrating with respect to x and then with respect to y. Finally we arrived at a is equivalent to 1. The next step is we should find fxy x comma y. So here we need to consider different cases of x and y to evaluate the fxy x comma y. See here x is taking values from 0 to 1, y is also taking the values from 0 to 1. So therefore the density function is this one. Is it? To consider the xy plane, x is lying in between 0 and 1, y is also lying in between 0 and 1. So therefore the density function is this region. So in this area, that fxy of x comma y is equivalent to x plus y is satisfied. But both y is lying in between 0 and 1, x is also lying in between 0 and 1. So this region, the shaded region, indicates fxy x plus y in the interval 0 to 1 and 0 to 2. Is it right? Now we have to evaluate this fxy x comma y. We already know that minus infinity to x, minus infinity to y. So fxy xy dx dt. Okay. So we have to find the volume under this function in the interval minus infinity to x and minus infinity to x. So in order to find it, first you have to take different cases. First let x is greater than or equivalent to 1 and y is also greater than or equivalent to 1. See, if x greater than 1 and y greater than 1, what this indicates? This fxy, x comma y indicates probability of, see, x greater than or equivalent to 1 and y greater than or equivalent to 1. Actually, we have to consider the event so this is an event in which both the conditions are satisfied, that is x greater than or equivalent to 1 and y greater than or equivalent to 1, because we are assuming x is greater than 1 and y is greater than 1. So here, so this region, this is x greater than 1. Similarly, this region is the y greater than 1. Is it? You can consider this portion and this portion, this region. Is it right? And if you consider x is greater than 1 and y is greater than 1, what is fxy of x comma y? 0. Is it 0? See, it is not 0 because we are including x equivalent to 1 and y equivalent to 1 also, and greater than those values. So here this region indicates greater than x, that is x greater than 1 and y greater than 1. But here we are also considering x equivalent to 1, y equivalent to 1. Consider x equivalent to 1, y equivalent to 1, and if you consider the joint event, then again we will get this entire region. Is it? So therefore I can write it as 0 to 1, x is taking value 0 to 1 and y is taking value 0 to 1, because this is the common region, x equivalent to 1 and y equivalent to 1, x equivalent to 1 and y equivalent to 1, that indicates this region. Okay, this portion. Understood? So therefore, in that interval, this fxy, x comma y is again x plus y dx dt. So this is equivalent to 1. Is it right? Now consider the second case. Let x is greater than or equivalent to 1, but y is lying in between 0 and 1. Y can take any value between 0 and 1, but x is greater than or equivalent to 1. So in this case, to draw the function, this is 1, this is also 1. So this region indicates x is taking values from 0 to 1 and y is also taking values from 0 to 1. So here x is greater than or equivalent to 1. So this region, is it? But y is lying in between 0 and 1. So this indicates y lying in between 0 and 1 and x greater than or equivalent to 1. So this region. So in this region, the condition is satisfied. Is it? Is it right? Sorry. Y is lying in between 0 and 1 and x greater, this region. y may take any value between 0 and 1, but x is taking values greater than or equivalent to 1. So therefore this region. Now if you consider the common region is 0 to 1 and 0 to some value y, is it? 0 to 1 because equality is included, and from 0 to some y value. What is this? This is y. Y is lying in between 0 and 1. Therefore, this fxy x comma y is equivalent to 0 to 1, but y is lying in between 0 to y, because this y can take any value between 0 and 1. Understood? So therefore this is x plus y dx. Here how much will you get? So this step is very important. Actually here this x can take any value and y can take any value. As a first case, first we considered x is greater than or equivalent to 1 and y is also greater than or equivalent to 1, and we obtained this value. Now we are letting x is greater than or equivalent to 1, but y is lying in between 0 and 1. It can take any value between 0 and 1. Okay. Therefore, you can consider this region, because this is taking any value between 0 and 1 and x is greater than or equivalent to 1. So as x is taking values greater than or equivalent to 1, see what is the common region here? Common region is this region, is it? So therefore we can consider 0 to 1 and 0 to 1. See, we are considering the events. This is an event and another event is x greater than or equivalent to 1, and this is the second event. So corresponding to this event, the region is this. This is the region. This and this will be satisfied here. Is it? How much you got? 1 by 2? 1 by 2? Y by 2 into 1 plus 1. What is the next possibility? So x may lie in between 0 and 1, y is greater than or equivalent to 1. So in this case, if you plot it, x, this is y, this is the density function lying in between 0 and 1. So x is lying in between 0 and 1. So therefore this region, any value. So x may take any value between 0 and 1. But y is greater than 1. So greater than 1 means this region. Here the event that we considered is this event. This is the joint event. So the common region is this region. Is it? So therefore, you can write fxy x comma y is equivalent to, this is 0 to 1, 0 to x, 0 to 1. So this is fxy x comma y dx. So in that region again it is 0 to x, 0 to 1, x plus y dx. What is this value? X by 2. In this case, x is lying between 0 and 1, y is also taking this. This is 1, this is 1, this is a fx density function. See, x is taking values between 0 and 1, y is also taking values between 0 and 1. So therefore, the region of interest is this. The event is 0 less than x less than 1 and 0 less than y less than 1. Therefore, this fxy x comma y is equivalent to 0 to x, 0 to y. Why we have written like this? This x may take any value between 0 and 1, y may take any value between 0 and 1. This is x plus y dx dt. How much? xy by 2. Any other possibilities? First we consider both x and y are greater than or equivalent to 1. Next we consider x is lying in between 0 and 1 but y is greater than 1. And next case is y is lying between 0 and 1 and x greater than 1. And then both x and y are taking any value between 0 and 1. So these are the terms. So therefore we can summarize and you can write this fxy of x comma y is equivalent to 1 for x greater than or equivalent to 1 and y greater than or equivalent to 1, and this equivalent to y by 2 into 1 plus 1. For x greater than or equivalent to 1 and this case is x by 2 into 1 plus x. Here finally xy by 2 into x plus y when verify whether this is valid or not. How can you verify whether it is valid or not? The first thing you have to check is fxy of x comma y should be greater than or equivalent to 0 for any value of x and y, and it should lie between 0 and 1 for any value of x and y. So those conditions must be satisfied. You check arbitrarily, select some values and check.